Hello, good evening once again. So, students, let us continue. And what was the last topic that we have discussed is half power frequency. Okay, we'll continue from that point. Let me draw a line. So, this is what. Now, we are going to start with new term. Okay, wet. I hope all is set. Just a bit. Okay, sorry guys, sorry to give you wait. And now it's all set. Now let's start with frequency response. Let me write, it is frequency response. Now what actually we are going to start with is a plot of frequency versus gain, and let me have this. Okay, let me draw it as large as possible. So this is x-axis, this is y-axis. What is there on y-axis? On y-axis we have gain in dB, and what is there on x-axis? We have frequency. So it is a plot of gain versus frequency. Now look at this, and you remember this is what? G max, maximum gain. Then whatever gain which is maximum, I need to subtract 3 from it, then draw a line. I hope it is a straight line. Yes, it is. And then the line where it cuts your frequency on x-axis, this is what your lower cutoff frequency, and this is your higher cutoff frequency. Remember that. And this is what? This is minus 3 dB level. This is minus 3 dB level. Now the question is, gain decreases at lower frequencies, gain decreases at higher frequencies. Now as I told you that this is what actual heart of our topic, heart of your chapter, that who is responsible to decrease the gain at higher frequencies as well as at the lower frequencies. Alright, now let me divide your frequency response into 3 parts. First is lower frequency. Okay, I'll write here lower frequency. This one is high frequency, and this one is mid frequency. Alright, we had this in last lecture. Now who is there to decrease the gain at lower frequencies? Is it? It means this dropping of gain at lower frequencies. Is it? Now if you check your circuit diagram of an amplifier, then you can conclude few things. Look at this, gain is decreasing at higher frequencies and gain is decreasing at lower frequencies. This portion that I'm talking about. Now if you observe your amplifier circuit diagram, okay, let me draw the small amplifier circuit diagram here. Look at this, this is collector resistor, then a transistor, is it, and then emitter resistor, bypass capacitor. I hope you remember that. One R1, one is R2, and then the voltage division is provided to the base. Is it? Somewhere here I will have a input coupling capacitor, then this is actual voltage source. Somewhere here let me ground it, and then this is output coupling capacitor. This is what my output. Now there is no need to keep track of all the names, but still we'll have it. This is RE. Okay, this is C out. So this is actually your amplifier circuit diagram. Let me call it as VS. So if you observe this amplifier circuit diagram, then Look at this. This is a frequency response of this circuit. A practical frequency response of an amplifier. Now frequency at lower frequency gain is decreasing, at higher frequencies gain is decreasing, and my job is to find out who is there to decrease the gain at lower and at higher frequencies. Right. So it means something or the gain is somewhere depend on the frequency. Frequency changes, gain changes. Is it? So look at the circuit diagram. In your circuit diagram, is there any component which is depend on frequency? Is there any component whose parameter actually depends on frequency? Yes, there is a component, that is capacitor, who is what we refer it as a reactive component. Look at this. This is reactive component. Reactive component means its impedance, virtually its impedance is depend on the frequency. You remember this XC. What is that XC? XC is capacitive reactance. In rough language, it is impedance offered by the capacitor. And what is the equation for that XC? It is 1 divided by 2 pi FC. It means, see, there is a frequency component. It means if frequency increases, look at this, if frequency increases, the capacitive reactance decreases. That's what the basic property of capacitor. Capacitor is a reactive component, and if frequency increases, the capacitive reactance decreases. Vice versa, if you decrease the frequency, then capacitive reactance will start increasing. Yes, it is or not. So it means capacitor is the component who is dependent on frequency, whose parameters are dependent on frequency, whose specifications, whose response is dependent on frequency. Is it? Look at this. We have proved the capacitor is the only component. See, transistor and then a resistor. No, but highly effective to the frequency is capacitor. So if frequency changes, capacitive reactance changes. So how many capacitors are there? Look at this. 1, 2, 3. 3 visible capacitors are there in the circuit. See, I used a word visible capacitors. That I have drawn, I can see them. Is it? So those 3 visible capacitors are responsible to decrease the gain at lower frequency. Look at this. Now at lower frequencies, bypass capacitor, that's what C. Look at this capacitor, and coupling capacitor. Coupling capacitor means I am talking about C out and C in. So those 2 capacitors are responsible to decrease the gain at lower frequencies. Is it? And that's all, because those are now visible. I know that at lower frequency they will affect. How they are affecting frequency response at lower frequencies, that we will discuss later. Is it? Initially what we are doing, सबसे पहले हम क्या कर रहे हैं, हम कंक्लूजन बना रहे हैं. कैसे कंक्लूजन हम बना रहे, ये हम बाद में सीखेंगे. On what basis I am taking that conclusion, I am drawing that conclusion, that we will study in next lecture. But for the time being हम सिर्फ conclusion बनाएंगे कि bypass capacitor and coupling capacitor are responsible to decrease the gain at lower frequencies. See, now those 3 capacitors are responsible at lower frequencies to decrease the gain. Yes, it is okay. But now what is there at higher frequencies? अभी तो कैपेसिटर खत्म हो गए सर्किट में. लुक एट दिस, ये कैपेसिटर तो गया, ये भी गया, तीनों कैपेसिटर तो खत्म हो गए. सो और कौन है जो हायर फ्रीक्वेंसी पे भी गेन को डिक्रीज कर रहा है? दैट्स व्हाट वी नीड टू थिंक. नाउ सम इनविजिबल कैपेसिटर्स. इट मींस लुक एट दिस, दिस इज आउटपुट लाइन. One capacitor is still present between a ground and your output terminal. इसको हम क्या बोलते हैं? Stray capacitance. Is it? The notation is CS. Look at this. stray capacitance. Is it? So this stray capacitance is responsible to decrease the gain at higher frequencies. कैसे, ये हम बाद में स्टडी करेंगे. पहले मैं क्या बता रहा हूं आपको, आई एम टेलिंग यू कंक्लूजन, आई एम टेलिंग यू द फैक्ट्स दैट बाईपास कैपेसिटर, कपलिंग कैपेसिटर, ये लोग हैं जो गेन डिक्रीज करते हैं एट लोअर फ्रीक्वेंसी. और स्ट्रे कैपेसिटेंस जो इनविजिबल है लेकिन सर्किट में होता है, ये रिस्पॉन्सिबल है गेन डिक्रीज करने के लिए एट हायर फ्रीक्वेंसीज. Is it? So is this the only component at higher frequencies? No. Again, look at this. There is a collector of a transistor, there is a base of a transistor, there is an emitter of transistor. So there is a capacitor in between these two terminals. Internal capacitance, transistor के अंदर जो capacitance होता है, that's what I'm talking about. And look at this. There is a small capacitance here. Is there a small capacitance here? So हर एक टर्मिनल के बीच में एक कैपेसिटर होता है, which is not visible, but it will come up at higher frequencies. Is it? वो पिक्चर में कब आता है? हायर फ्रीक्वेंसी में पिक्चर में आता है वो. And those internal capacitor of transistor. Look at this. This is first and this is second. So those internal capacitance of a transistor are responsible to decrease the gain at higher frequencies. Now that's what the conclusion is it. और उसके बाद हम क्या सीखेंगे, is what we will discuss after that, कि कैसे, how bypass capacitor and coupling capacitor are responsible to decrease the gain, how stray capacitance and internal capacitance are responsible to decrease the gain at higher frequencies. Right? So I'm telling you the conclusion now, and hence we will start with one by one. पहले हम क्या करेंगे, पहले हम bypass capacitor का इफेक्ट देखेंगे, उसके बाद हम coupling capacitor का इफेक्ट देखेंगे. What will be the effect? Effect is known. What is the effect? Effect is that gain will decrease. And then we will discuss about internal capacitance and stray capacitance, how they are decreasing the gain. Is that? Now, so all this is clear. Is that the conclusion part? A small conclusion. कौन है जो गेन को डिक्रीज कर रहा है एट लोअर फ्रीक्वेंसी, कौन है जो गेन को डिक्रीज कर रहा है एट हायर फ्रीक्वेंसी, दैट्स व्हाट ओनली. इज इट? तो कैसे करते हैं वो लोग, दैट वी विल डिस्कस इन नेक्स्ट पार्ट नाउ. इज इट? सो कैन वी स्टार्ट देन नाउ. Let us come to the original session again.